Hi everyone, myself B. Praveena. I am the Assistant Professor of Mathematics in Institute of Aeronautical Engineering College. Today I want to discuss about my topic is Fourier series. Okay, what is Fourier series? First I'll discuss with the introduction part of that. Okay, that is Fourier series, which was named after the French mathematician Jean-Baptiste Joseph Fourier. Okay, in the years 1768 to 1830, Fourier series and infinite series representation of periodic function in terms of trigonometric sine and cosine functions. It is very powerful method to solve ordinary and partial differential equations, particularly with periodic functions appearing as non-homogeneous terms. Okay, we know that Taylor series expansion is valid only for functions which are continuous and differentiable. Fourier series is possible not only for continuous functions but also for periodic functions, functions which are discontinuous in their values and derivatives. Because of the periodic nature, Fourier series constructed for one period is valid for all. Fourier series has been an important tool in solving problems in many fields like current and voltage in alternating circuit, conduction of heat in solids, and electrodynamics, etc. Okay, mainly that Fourier series is uh, represented with the periodic function in terms of trigonometric sine and cosine functions. It is very powerful to solve ordinary and partial differential equations, particularly with the periodic functions. Have to solve that ordinary and partial differential equations with particular functions. Okay, for that, before going through discussing about the Fourier series, this is mainly useful for what? For the periodic functions with to solve ordinary and partial. For that case, first we have to discuss what is periodic function. What is periodic function? Periodic function means a function f maps R to R is said to be periodic if there exists a positive number t such that f of x plus t is equal to f of x for all x belongs to R. f of x plus t is equal to f of x for all x belongs to R. Then t is called as a period of f of x. If a function has a smallest period t greater than 0, then this is called as fundamental period of f of x or primitive period of f of x. What about the definition for the periodic? F of x plus t is equal to f of x. If you are taken any value of t, again we get the same function, then that is called as a periodic function. Here the periodic smallest period t greater than 0. Okay, here the examples sin x, cos x are periodic functions with primitive period 2 pi. With primitive period 2 pi. For example, sin x, I'll check is it periodic function or not. Okay, sine of x plus 2 pi. Sine of x plus 2 pi is equal to what? Sin x. Similarly, sin x plus 4 pi, that period is equal to, again, that is equal to sin x. If you have taken any value of in terms of 2 pi, 4 pi, 6 pi, again we get the same function. Therefore, the sin x is a periodic function with the period 2 pi. And similarly, cos x. Cos x periodic function with the period 2 pi. And sin nx and cos nx are periodic functions with the primitive period 2 pi by n. And tan x are periodic functions with the primitive period pi. And tan nx are periodic functions with the primitive period pi by n. With the primitive period pi by n. If f of x is constant, is a periodic function, but it has no primitive period. Right? Okay. If f of x is any constant, for that it is a periodic, but it has no primitive period. Note, any integral multiple of t is also a period If f of x is a periodic, then f of x plus nt is equal to f of x, where t is period, where t is a period. T is a period. If f1, f2 are the periodic functions having same period t, then f of x is equal to what? C1 f1x plus C2 f2x. C1, C2 are the constants of t. If t is the period of f, then f of C1x plus C2x are also has the period t. If f of x is a periodic function of f of x of period t, then f of x ax, a not equal to 0, is periodic function of x of period t by a. If the function f of ax, for that case, what about the period of that? T by a. If f of x by b not equal to 0 is a periodic function of x, then period is equal to tb. Then, okay, after that, what about even function and odd function? A function f of x is an even function if f of minus x is equal to f of x. Example, f of x is equal to cos x comma x square. If you have taken any function, for example, x square, according to the definition, minus x whole square, this is equal to what? F x square. If you have taken any function of f of minus x is equal to f of x, therefore f of x is a even function. What are the examples for that? X square, one example, and cos of minus x is equal to, again we get the same function, that is cos x. This is the graph for the even function. And the graph of even function y is equal to f of x is symmetrical about the y-axis. This is symmetrical about the y-axis. If f of x is an even function, then integral minus a to a f of x dx is equal to 2 into integral 0 to a f of x dx. This is the formula. Okay. And next, odd function. A function f of x is said to be odd if f of minus x is equal to minus f of x. Example, f of x is sin x comma x cube. The graph of odd function y is equal to f of x is symmetric about the region. If f of x is odd function, integral minus a to a f of x dx is equal to 0. What about the graph for that? It is symmetric about the origin. This is the graph for that. And what about the formula for that? If f of x is odd function, means for that case, integral minus a to a f of x dx value is equal to 0. Next, note, there may be some functions which are neither even nor odd. Okay, which one? That is 4 sin x plus 3 tan x minus e power x. The product of two even functions is even. The product of two odd functions also even. The product of two even functions is even, and the product of two odd functions is even. The product of an even and odd function is odd. Okay, this is the important point. The product of one even and odd function is all odd number. The product of the even function is even. The product of the odd function is also even. These three are the very important points. Okay, these are useful for the next problems. Trigonometric series. A series of the form f of x is equal to a naught plus a1 cos x plus a2 cos 2x and so on, and plus b1 sin x plus b2 sin 2x plus b3 sin 3x and so on. Then write it as that f of x is equal to a naught plus sigma n is equal to 1 to infinity an cos nx plus bn sin nx. Conditions for the Fourier series expansion. A function f of x is defined in 0, 2 pi has a valid Fourier series expansion of the form f of x is equal to a naught by 2 plus sigma n is equal to 1 to infinity an cos nx plus bn sin nx. Here a naught, a and bn are the constants provided. F of x is here. What about the nature of the f of x? Here f of x is well defined with a single valued except possibility finite number of points in the interval 0, 2 pi, and f of x has finite number of discontinuous in the interval 0, 2 pi, and f of x has finite number of finite maxima and minima. The above conditions are valid for the function defined in the interval minus pi comma 0 comma 2l. Okay, here cos 1x, cos 2x, and cos nx. Consider any two. All these have a common period 2 pi, right? And here cos 1, cos 0x, cos pi x, cos 2 pi x. All these have a common period 2l. These are called complete set of orthogonal functions. Euler's formula. Okay, from the basics now we have to get the Fourier series formula. This is called as Euler's. What is that formula for that? The Fourier series of the function f of x in the interval c less than or equal to x less than or equal to c plus 2 pi is given by f of x is equal to a naught by 2 plus sigma n is equal to 1 to infinity a n cos nx plus b n sin nx. What about the formula for the a naught? That is 1 by pi into integral c to c plus 2 pi f of x dx, and an is equal to 1 by pi integral c to c plus 2 pi f of x into cos nx dx, and bn is equal to 1 by pi integral c to c plus 2 pi f of x into sin nx dx. Okay, this is the formula for the Fourier series, and these are the formulas for a naught, an, and bn. These values are known as Euler's formulae. Okay, for that, find the Fourier series expansion of f of x. Now, I'll discuss with that, with the concept of the Fourier series with the first question with the interval 0, comma 2 pi. Okay, find the Fourier series expansion of f of x is equal to x square within the limits 0 to 2 pi. Hence deduce that. Okay, first find out the series, and after that deduce 1 by 1 square plus 1 by 2 square plus 1 by 3 square value is equal to pi square by 6. And the second one, 1 by 1 square minus 1 by 2 square plus 1 by 3 square is equal to pi square by 12. And the third question, 1 by 1 square plus 1 plus 1 by 3 square plus 1 by pi square is equal to pi square by 8. Once observe, what about the interval point? Interval limits 0 to 2 pi. For that case, for the same question within the interval minus pi comma pi means, for that case we have to verify the function is even or odd. But the thing is here, but the question is here f of x is equal to x square. What they are asking within the limits 0 to 2 pi. For that f of x is equal to, what about the formula for this? A naught by 2 plus sigma n is equal to 1 to infinity Pn cos nx plus Bn sin nx. Then what about the formula of a naught? 1 by pi into integral 0 to 2 pi f of x dx. That is 1 by pi into integral 0 to pi x square integration x cube by 3. What are the limits for that? 0 to 2 pi. That is 1 by pi into 8 pi cube by 3 minus 0. That is here 1 pi cancel, then directly whatever the answer for that, 8 pi square by 3. And an, whatever the formula of an? 1 by pi into integral 0 to 2 pi f of x into cos nx dx. Once observe, which is in, after substituting there in place of f of x as function x square into cos nx. Once observe within the limits 0 to 2 pi, whatever the integration of x square cos nx, which is in the form of integral uv. For that case, x square into, whatever the formula, let us take x square as u and this as v. Okay, then u into v. V means cos nx integration, that is sin nx by n, minus x square differentiation 2x, and sin nx by n integration is minus cos nx by x coefficient there n, already there n into n square, plus 2x differentiation 2 minus cos nx by n square integration, already minus cos nx integration is sin nx by n cube. What are the limits for that? 0 to 2 pi. Okay, now substitute the limits. That is 1 by pi into, substitute the limits here, x square limit. Okay, now I'm substituting there. That is 1 by pi into 2 pi whole square sine 2n pi by n plus 2 into 2 pi into cos 2n pi by n square minus 2 into sine 2n pi by n cube. This is the substitution of the upper limit minus 0 square into sine n of 0 by n plus 2 into 0 of cos n of 0 by n square minus 2 into sin n of 0 by n cube. This is the substitution of the limit point. From that there sin 2n pi value, directly we know that sin 2n pi value 0 and cos 2n pi value 1. That means here sin 2n pi value 0, that is first one, and cos 2n pi value 1, 2 pi into 2, that is 4 pi by n square, and sine 2n pi value 0, and there sine 0 0 and cos 0 minus sine 0. Okay, then here 2 into 0, then this is also completely the second part after the substituting the limits, upper lower limit point, then directly that is equal to 0. Here once observe sin n pi value is minus 1 whole power, sorry, sin n pi value 0 and sin 2n pi value is 0 and cos 2n pi value 1 and cos n pi value minus 1 whole power. These are the main concept of this cos n pi value minus 1 whole power n. There I am substituting in place of cos 2n pi as 1. Therefore, that is 4 pi into 1 by 1 square, n square. Therefore, here pi cancel, then directly 4 by n square as the an value. Next, bn. What about bn? 1 by pi into integral 0 to 2 pi f of x sine nx dx. There 1 by pi into integral 0 to pi x square sine nx. Okay, again which is in the form of uv. Then okay, now I'll find out that 1 by pi into integral of x square into sin nx integration minus cos nx by n minus 2x into cos nx integration minus sin nx by n square plus 2 into, again sin nx integration, already minus, there minus, plus cos nx by n cube, cos nx by n cube. What are the limits for that? 0 to pi. What are the limits for that? 0 to 2 pi. Okay. This is the formula for the UV formula for x square into cos nx. Then after writing that UV formula, now substitute the limit point, that is 2 pi whole square into minus of cos 2n pi by n plus 2 into 2 pi into sin n 2 pi by n square plus 2 into cos 2n pi by n cube minus of, if you are substituting 0, first term as 0 and here substitute 0, that is also 0, plus 2 into cos n of 0 by n cube, 2 into cos n of 0 by n cube, that is 1 by pi into there 4 pi square cos 2n pi value 1, there minus by n, sin 2n pi value 0 and 2 by n cube into cos 2n pi value 1, and next minus of 2 into cos 0 value 1 by n cube, There once observe these two are cancelled and directly their pi cancel. Therefore 4 pi into minus 1 by n, that is minus 4 pi by n as bn. That is minus 4 pi by n is equal to bn. Okay. Now we know that an value, a naught value and bn value. Now substitute these all values in the series, that is a naught by 2 plus sigma n is equal to 1 to infinity an cos nx plus bn sin nx. Okay, what about a naught value? 8 pi square by 3 into 1 by 2 and an value 4 by n square into cos nx. And what about bn? 4 pi by n minus 4 pi by n into sine nx. After substituting all, now expand the sigma value here. Okay, here 8 to 4 pi square by 3 plus 4 into n value starts from 1. I'm taking 4 outside, that is cos 1x by 1 square plus n is 2 cos 2x by 2 square plus cos n is 3 cos 3x by 3 square minus 4 pi into sine n value starts from 1x by 1 plus sine 2x by 2 plus sine 3x by 3. Okay, this is the required series for the function f of x is equal to x square within the limits 0 comma 2 pi. Okay, after getting the series, let us take this as the second equation. In that second equation, okay, and here this f of x means what? X square. For the finding reduction part, let us assume x value. Then let x is equal to 0. Substitute in the second equation. Substitute in the second equation. From that, 0 square is equal to what? 4 pi square by 3 plus 4 into cos 0 by 1 square plus cos of 2 of 0 by 2 square plus cos of 3 of 0 by 3 square minus 4 pi into sine of 0 by 1 plus sine 2 of 0 by 2 plus sine 3 of 0 by 3 and so on. From that from that 4 pi square by 3 plus 4 into cos 0 value 1 and okay, therefore and 1 by 2 square cos 2 of 0 and this is 1 by 3 square minus 4 pi into sine 0 0 sine 2 of 0 0 and sine 3 of 0 0 here 0. From that series there 4 pi square by 3 0 equal to plus 4 into 1 plus 1 by 2 square plus 1 by 3 square and so on. For that 4 pi square by 3 is equal to minus 4. There 4 cancel, that is 1 plus 1 by 1 square plus 2 square plus 1 by 3 square and so on. This is equal to how much? Pi square by 3. And observe the question, pi square by 6. Where is that? See. 4 pi square by 3 plus 4 into square plus 1 by 3 square by 6. There x square, let us x is 0, that is 4 pi square by 3 plus 4 into 1 plus 4. Okay, therefore here we get the answer for this 1 plus 1 subserve there 2 cos 2x 1 by 2 square cos n into cos nx may be 1 subserve n into cos nx n cancel. Okay, okay, there n is missing. If you are substituting there directly, here we get 6. That is 1 plus 1 by 2 square plus 1 by 3 square and so on is equal to pi square by 6. For the second deduction part, let us take x is equal to pi. Okay, from that we get the second deduction. Okay, and after adding that second, what about the, let us take this as the third equation and fourth equation and 1 by 1 square. Okay, if you are substituting that from that second deduction, 1 by 1 square minus 1 by 2 square plus 1 by 3 square and so on is equal to pi square by 12. Pi square by 12. Pi square by 12. Let us take this as the fourth equation. Adding 3 plus 4. Adding 3 plus 4. If you are adding the 2 here, okay, that is 1 plus 1 by 2 square plus 1 by 3 square and so on is equal plus 1 by 1 square minus 1 by 2 square plus 1 by 3 square and so on is equal to pi square by 6 plus pi square by 12. There plus 1 by 2 square and minus 1 by 2 square cancel. Okay, these two are cancelled. Then series 1 by 1 3 square and 1 by 1 by 5 square and so on is equal to, directly after the simplifying this, that is 2 pi square plus pi square by 12, that is 3 pi square by 12, that is pi square by 4. Here, after adding the 2, here, there, this is equal to 2 into there. Here I'll take 1 plus 1 by 3 square plus 1 by 5 square and so on is equal. If you are taking 2 on this side, that is equal to 2. Therefore, final answer for that, pi square by 8. This is the required Fourier series and the deduction parts for this. Okay, this is the answer. Okay. This is the concept for finding the interval within the interval 0, 2 pi Fourier series problems. Thank you. Next class we will discuss with the other concept with minus pi, pi interval and 0, 2l and minus l, l. Okay. Thank you. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.